Welcome to 3.4. We're going to be talking about linear equations in one variable. So essentially, we're going to be solving equations using the addition, subtraction, multiplication, and division properties of equality. We sometimes may have to simplify things before we do that, but we're essentially just going to be putting those skills together. So let's go ahead and have a look. So these are the steps to solve a linear equation in one variable. And it'll make more sense when we do a couple of examples. But let's talk about the basic steps. So step one, simplify each side of the equation as much as possible. This step is done using the commutative, associative, and distributive properties. So we want to distribute whenever appropriate. We want to add, subtract, multiply, and divide in order to simplify as much as possible. And then once we've done that, then we will get into kind of the meat of solving, isolating the variable by using the addition and subtraction properties of equality to get all the variable terms on one side of the equation and all constant terms on the other side. Then we'll combine the like terms. A variable term is any term that contains the variable. A constant term is any term that contains only numbers. Then step 3. Use the multiplication or division property of equality to get the variable by itself on one side of the equation. Then step 4, check your solution, see if in the original equation if you think it is necessary. And so that'll depend on one, maybe the level of challenge of solving the equation, the likelihood of making a mistake, right, as the challenge increases. And the other part of it could be that you want to check an elaborate equation to see if you're right. So, and as you get more practice, you'll be more confident in which ones need checking. All right, so let's go ahead and have a look at this first example. So solve 3 times x plus 2 equals negative 9. So the directions are solved. So whenever the directions are solved, we are trying to isolate the variable, trying to solve for the variable, trying to get the variable on a side by itself. So to do that, sometimes we have to simplify first. And they're not going to say simplify. We're going to have to know that that's a part of solving. Solving means simplify first, then use the addition and subtraction properties of equality, then use the multiplication and division properties of equality, and then you can check if necessary. So here, we're going to distribute the 3 to the terms inside. So that's 3 times x plus 3 times 2 equals negative 9. Now I'm going to simplify here. 3 times x is 3x plus 3 times 2 is 6. So I've simplified as much as I can by using the distributive property, and I've combined any like terms. There were none. So now I can use the addition and subtraction properties of equality. So in this case, I have a variable term on the left and a constant term on the left, and I have a constant term on the right. So I want to get my constant terms together. So I'm going to undo whichever constant term is doing something to my x, my variable. In this case, 6 is being added to my variable term, so I'm going to subtract 6 from both sides in order to zero it out on one side. So 3x is all that's left on the left because I subtracted 6, and I subtracted 6 from the right. Negative 9 minus 6 is negative 15. Now that I've used the addition and subtraction properties of equality, I can use the multiplication or division property of equality. I know what 3 times x is equal to, but I want to know what just x is equal to. So the opposite of multiplying by 3 is dividing by 3. And as long as I do it to both sides, I can keep the equation balanced and true. So 3 divided by 3 is 1. So x equals negative divided by positive is negative. 15 divided by 3 is 5. If I'm not sure about this, I can take it up here and I can check it. Negative 5 plus 2 is negative 3 times 3 is negative 9. Yep, checks out. Okay, let's look at another one. Again, this one just says solve. It says solve 2 times the quantity x minus 4 plus 5 equals negative 11. So this one's got some simplifying to do before I can start using the addition, subtraction, or multiplication and division properties of equality. So let's go ahead and do that. I've got to distribute this 2 to the terms inside parentheses here. So it's 2 times x minus 2 times 4. So this minus I'm just bringing down here. And since this didn't have a negative, I didn't worry about using extra parentheses. It's just 2 times 4. So, and then bring down the plus 5 equals negative 11. Okay, now I've got to do this multiplication. 2 times x is 2x. Negative 2 times 4 is negative 8, so minus 8. Right? And I knew if I doubled x and I doubled minus 4, I'd get minus 8. Plus 5 equals negative 11. Now I'm not done simplifying. I have like terms here. Negative 8 plus 5, that's negative 3. So I have 2x minus 3 equals negative 11. Now that I've simplified as much as I can by distributing through parentheses and combining like terms wherever possible, now I can use the addition subtraction property of equality to say, I have this 2x term on the left, and I have a minus 3 with it. I want to get rid of that, so I want to add 3 to both sides. So minus 3 plus 3, that makes a 0. So all I have left on the left is 2x equals negative 11 plus 3 is negative 8. Oh, I'm not done yet. I thought I was done there for a second, but I'm not, because I have 2x equals negative 8, and I want to know what a single x is. So what's the opposite of multiplying by 2? Dividing by 2, and as long as I do it to both sides, then I can do that. So 2 divided by 2 is 1, so I get just x equals negative 8 divided by 2 is negative 4. Half of negative 8 is 4. Negative 4. So if I want to check this, I can then take it up here and I can check it and see if it's true. Let's do another one. This one is a little more complicated because it looks like we have variables on both sides. So the first thing we're going to want to do in order to solve for x is simplify as much as possible. So we'll use the distributive property to distribute through parentheses. So 5 times 2x is 10x. 5 times minus 4 is minus 20. And everything else just comes down. Now I have some like terms here. So negative 20 plus 3 is negative 17. Okay, so 10x minus 17 equals 4x minus 5. Now, the trouble is here that I have variable terms on both sides of the equation now, both left and right. So what I want to do now is I want to put my variable terms on one side of the equation. So what I'm going to do is I'm going to zero out the variable term on one side. So in this case, I'm going to go after the smaller variable term, that's 4x. I'm going to go after that one, and I'm going to zero that one out. So I'm going to take away 4x. Let me show you. I'm going to take away 4x from both sides. Remember, whatever I do to one side, I have to do to the other side to keep it balanced. And I'm taking away 4x because 4x minus 4x is 0. So it zeroes that term out, and then it gets integrated on the left-hand side because I've subtracted it from both sides. Now 10x minus 4x, that's 6x, bring down minus 17, equals negative 5. Now I have my variable terms together, so what I want to do is get my constant terms together. And I want to get them on the side opposite of x. So in this case, I have all my x's on the left. I want to get all my constants on the right. So I'm going to go after this 17 here by adding 17 to both sides. So now I have 6x equals negative 5 plus 17 is 12. Now I have 6x equals 12. Let me just come up here for a second so I have enough room to work. So if 6x equals 12, I want to know what x equals. That's my goal, to get a single x. X equals some number. So if I know what 6x's are, I could maybe figure this out. 6 times what gets me 12? Okay, so I think I know, but the way we want to solve this so that I could do it with any numbers, no matter how big or complicated they get, 6 times x, well, the way to undo that, the opposite of multiplying by 6, is dividing by 6. And as long as I divide both sides by 6, then it will remain a true and balanced equation. So 6 divided by 6 is 1x. That's exactly what I wanted. 12 divided by 6 is 2. So that is the solution to this equation, x equals 2. And I can check it. Right? I can check it to see if it stays balanced. So let's review 3.4. This is where we kind of put together all of our techniques for solving equations, right? The addition and subtraction property and the multiplication and division properties of equality. But what's the first step whenever we're solving an equation? The first step of solving a linear equation in one variable, which means there's a single variable and we are trying to isolate it, the first step is always to simplify. Simplify as much as possible using the distributive property often, and then combining like terms using the associative and commutative property, which means you can associate and order multiplication and division in the way that is helpful for you. So simplify is key. B, why should you get all the variable terms on one side of the equation and all the constant terms on the other side? Because your goal is to isolate the variable on a side by itself. And to do that, you have to get all the variable terms on one side and all the constant terms on the other side as part of that process. So the goal is to isolate the variable. So that's why. Why should you get all the constant terms on one side and the variable terms on the other side? Because your goal is to isolate the variable. All right, let's have a look at C. Write the equation that results when 4a is subtracted from both sides of the equation below. Okay, so they said, take this equation, 6a plus 9 equals 4a minus 3. And they said when 4a is subtracted from both sides. So let's see. Let's subtract 4a from both sides and see what results. So 6a minus 4a, that's 2a, still plus 9, equals 4a minus 4a is 0. That's exactly what we might expect if we were canceling one of the variable terms, right, and trying to combine the variable terms into a single variable term. And then this minus 3 has to come down. So that's the equation that would result if you subtracted 4a from both sides of that equation given. So hopefully that made sense, putting together all of these properties in order to solve linear equations in one variable, which is just a fancy way of saying solving an equation with a single variable. And if you have any questions, be in touch. Otherwise, I will see you in the next section. We're going to skip 3.5 and we're going to head right into 3.6.